All right, so graph or sign chart, both good ways to solve a polynomial inequality that is generally going to have one or more interval solutions. I'm going to recommend that the graph is preferable because notice how I didn't have to test 3 intervals. All I had to do is find the x-intercepts, which I also had to do here, and know that it's an upward parabola. Once I've found the x-intercepts and I know that it's upward facing parabola, then I know which intervals are positive and which are negative. I don't have to test the intervals. And if this had been greater than 0 instead of less than 0, I would know that the solution would be negative infinity to negative 2.92, union 2.92 to infinity. So graphing is better. The only reason people do sign charts is because they don't know graphs very well, and you need to know graphs very well. You need to be able to graph any polynomial graph just by factoring, finding the x-intercepts, knowing end behavior, and multiplicities. And if you don't know what I'm talking about, send me an email and I'll explain it to you. All right, now, next up. We wanted to verify that it is true that r of delta t is within 10 of the limit. So what we did here is we said, where am I? If I want to be within delta t of the limit, that's what this inequality says, then I just need to pick a delta t in this interval. And by the way, since delta t is positive, I can throw out the negative values and just say that as long as delta t is less than 2.924, did I say? 2.9235. So what I'm going to do is go with 2.923, because if delta t is less than 2.923, then it's definitely less than 2.9235, which is what square root of 10 over 1.17 is. I mean, I could say delta t less than square root 10 over 1.17, but I want to keep it a little bit sort of comprehensible here. If delta t is less than 2.923, then the absolute value of r of delta t minus L is going to be less than 10. That's my claim that I want to verify. All right, so how am I going to verify it? I'm going to say, what is r of 2.923? So I could copy and paste, but it's pretty easy to go var is y1, and we're going to put in positive 2.923. Now, delta t is really supposed to be less than 2.923, and I put equal to 2.923, but remember, delta t is really supposed to be less than the square root of 10 over 1.17, and 2.923 is less than 10 over square root of 10 over 1.17, because that number is 2.9235 with some decimals after it, all right? So I can verify that if I use 2.923 and find out what I get negative 2203.746. Negative 2203.746. Now, is that within 10 units of negative 2193.75? Yes, it is within 10. All right, it's a distance of less than 10 from this point to this point. All right, so that is my verification that in fact, where's my page? That in fact, I'm within within 10 of the limit. All right, so now we're just going to continue that because this is the process with calculus. We do something with a certain number and we make that interval be smaller and smaller and smaller until it is the smallest positive number, which doesn't exist. That's what we're headed for. All right, so let's go to 5 next. All right, so repeat the same steps. So if you haven't already done this, now you know how to do it. Just go ahead and do it. And make sure that you can follow the process. So, yeah, here we go. So this is number 6. So we're going to still solve, I'll still write this part out, negative 2193.75. We're going to find eventually we can dispense with some of this, minus 1.17 delta t squared plus 2193.75 is less than 5, all right? And that's my absolute value of r of delta t minus L, and L was a negative number, so that's why we ended up with a positive there. All right, less than 5, that's what we're doing. Okay, then the 2193.75s cancel again. We have absolute value of negative 1.17 delta t squared. It's starting to be monotonous and predictable, which is good because it means we're detecting a pattern. So we can say 1.17 delta t squared is less than 5. So we can solve that by doing 1.17 delta t squared minus 5 is less than 0. We'll make that a graph of that. This is parabola centered with vertex at the origin, vertical expansion, and vertical translation of 5. So the vertex is at negative 5, 0, and it goes up like this. So we find these x-intercepts, and we're less than 0 when we're in between the x-intercepts because that's where the graph is below the x-axis. So all I need to do is find out what these x-intercepts are. I find the x-intercepts by solving 1.17 delta t squared minus 5 equals 0. And so it's pretty easy to see that I'm going to have delta t equals the square root of 5 over 1.17. Yeah, so, and in fact, I already have a similar expression right here. So using our calculator tricks, we can just press enter to copy it down and then go up here. This is taking advantage of patterns on our calculator. We can delete one of these digits and then put a 5 there and then enter, and we get 2.067. All right, so delta t is approximately equal to 2.067. And once again, I've rounded down by truncating. That way, my delta t being less than this number will guarantee that I'm going to satisfy this inequality up here. All right, so that's my x-intercepts. So I know that my interval is where the graph is negative. It's between here and here. All right, so my solution to my inequality is delta t is an element of the interval negative 2.067 to positive 2.067. And because delta t is positive, I'm going to restrict that to delta t is less than 2.067. All right, so now I've solved that inequality using the same steps. And of course, the more times you do it, the quicker it's going to get. We want to verify our result. So remember our goal here is I'm saying that if delta t is less than 2.067, then my calculated value, r of delta t, is going to be within 5 units of the limit. All right, well, let's see if that's true. So I'm just going to do r of 2.067, so I can just come up here, get this, enter 2.067. So now I'm finding r of 2.0. How about 0.67? All right, and then enter. And I get negative 298.748. All right, so r of 2.067, remembering that 2.067 is really less than square root of 5 over 1.17. But r of 2.067 is equal to negative 2198.748. Is that within 5 units of negative 2193.75? Is it within 5? Why, yes, it is. All right, so there you go. Now we're just going to continue this. And what if we want to be within 1 of the limit? What if we want to be within 0.1 of the limit? What if we want to be 0.01 of the limit? We can always find a value of delta t that is going to get us within the prescribed amount of the limit. And that is the definition of what a limit is, which we will explore next.